Day 460 of doing a LeetCode problem every day until I get a job. Alright y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3479, fruits in the baskets 3. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given two arrays of integers, fruits and baskets, each of length n, where fruits of I represents the quantity of the ith type of fruit and baskets of j represents the capacity of the jth basket. From left to right, place the fruits according to these rules. Each fruit type must be placed into the leftmost available basket with a capacity greater than or equal to the quantity of that fruit type. Each basket can hold only one type of fruit. If a fruit cannot be placed in any basket, it remains unplaced. Return the number of fruit types that remain unplaced after all possible allocations are made. Alright y'all, so if you've been following along this channel, you know this question seems mighty familiar. It seems really close to the question we did yesterday, which is fruits in the baskets 2. The only difference between the two questions is the constraints down here. These constraints, we have a much larger group of inputs. Our inputs are much larger in this question, and that's what makes all the difference when we are coming up with the solution for this question. So if you haven't done yesterday's problem, which is fruits in the baskets 2, I suggest you go check that out. I think it's day 459. So go ahead and check that out. It's an easy problem. It's the easier version of this problem. So go ahead and check that out if you have not already. And if you have, let's get into these examples. So in example 1, fruits equals an array of integers 4 to 5. Baskets equals an array of integers 3 and 4. The output is 1. Explanation says fruits of 0 equals 4 is placed in baskets 1, which equals 5. So it says right here, each fruit type must be placed in the leftmost available basket with a capacity greater than or equal to the quantity of that fruit. So this array represents the quantity of the fruit, and this array baskets represents the capacity of each basket. So since our first fruit at index 0 right here, which equals 4, there's 4 fruits, we put it in basket 1 because basket 1 has a capacity of 5. So 4 fruits cannot fit into a basket that can only hold 3 fruits. However, 4 fruits can fit into a basket that can hold 5 fruits. So we're going to place these 4 fruits into this basket. Boom. Then we're going to look at fruits of 1, which equals 2. We're going to place that in baskets of 0, which equals 3. So these fruits right here, there's only 2 of them. Since we haven't used this basket yet, we could put these 2 fruits into this basket and then keep going. So in fruits of 2, which equals 5, cannot be placed in the baskets 2 because basket 2 only equals 4. So our next group of fruits, there are 5 fruits, but our last basket only has a capacity of 4. So 5 fruits cannot fit in a basket that can only hold 4 fruits. So we have one fruit type that is unplaced, and that's what we want to return. It says return the number of fruits that remain unplaced after all possible allocations. Since these fruits cannot fit into this basket, that means these fruits are going to be left unplaced. So you might be asking why we can't just put these fruits into this basket, but remember, we have to put the fruits in the leftmost available basket. So in this case, 5 is the leftmost available basket. That's why we have to put these 4 in this basket that holds 5, which leaves these 5 fruits unplaced. So we return 1 because we have one group of fruits, or one type of fruit that remains unplaced. So let's take a look at example 2. Example 2 is where all of the fruits can fit. So in example 2, we have our input fruits equals an array of integers 3, 6, and 1. Our baskets equals an array of integers 6, 4, and 7. This time our output is 0. Explanation said fruits of 0, which equals 3, is placed in baskets of 0, which equals 6. So we could take these 3 fruits, and we can place them in this basket right here, which can hold 6 fruits. Then it says fruits of 1, which equals 6, cannot be placed in basket 1 because basket 1 equals 4 and there's insufficient capacity, but can be placed in the next available basket, which is baskets of 2, which can hold 7 fruits. So we could take these 6 fruits and place them in this basket that can hold 7 fruits. Boom. Then finally, last but not least, fruits of 2, which equals 1, is placed in basket 1, which equals 4. So this one fruit right here can fit. There's only one basket left, and that basket has a capacity of 4. Luckily, we only have one fruit, so this one fruit can fit in this basket, which means since all of the fruits are successfully placed, we return 0 because there are no fruits that were left out or no fruits that were unplaced. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult. It's a little bit more lengthy than yesterday's solution, but nothing we can't handle. So let's get into it. Now, the first thing we're going to do is we are going to create our own separate class. We're going to create a class for our segment tree that we're going to use. So we could just say class. We can come outside of this class right here. Come outside of this, and we're going to create a new class, and we're going to call this class segment tree. Boom. Sorry, y'all. Segment tree. Boom. Then we need to create our segment tree array, which is going to store the maximum basket capacity in each segment. So we can declare a variable, call it tree, we'll say colon, and we'll set that equal to an array of integers. Boom. Now we need the number of baskets, so we can declare a variable called n, and we'll just set that, cast that as an integer. Boom. Then we're going to initialize these by saying init, open up the parentheses, underscore r, colon, array of integers, come outside of that parentheses and open up the brackets. We're going to say n equals r dot count. Then we're going to say tree equals an array, open up the parentheses, repeating, colon 0, comma, count, colon 4 times n. And that's enough size for the segment tree. Now we need to build a tree from the basket capacity. So, well, first thing we're going to do is, first let's do this. Let's handle this build function first before we initialize it. So we're going to create a build function which is going to build the segment tree. Each node is going to store the maximum capacity in its range. So we're going to say func build. Going to open up the parentheses. We're going to say underscore r. Sorry, y'all. It should be r colon. That's going to be an array of integers. Come outside that square bracket, and we're going to say underscore node colon. That's going to be an integer. Then we're going to say comma underscore start colon. That's going to be an integer. And then we're going to say underscore end colon. That's going to be an integer as well. We're going to come outside these parentheses and we're going to open up the brackets. We're going to say if start equals end. Then we're going to open up the brackets, and the leaf node is going to be the single basket capacity. So we're going to say tree square bracket node. Come outside of that, and we're going to set that equal to r square bracket start. Boom. Then we can come right here on the if, and we're going to say else. We're going to say let mid equal, open up the parentheses, start minus end, come outside the parentheses and divide that by 2. Then we're going to say, use some recursion, we're going to say build, open up the parentheses, we're going to pass in r, comma 2 times node, comma, start, comma, mid. Boom. And that's going to build the left child. Now we need to build the right child by saying build Open up the parentheses. We're going to say r comma 2 times node plus 1 comma mid plus 1 comma end. And that's going to build the right child. Then we need to store the maximum capacity of both children by coming underneath that. We're going to say tree, open up the parentheses, node. We're going to set that equal to max, open up the parentheses, tree, square bracket 2 times node, come outside that square bracket, comma, tree, square bracket 2 times node plus 1. Boom. Now, we're not done yet because we still need to initialize this function up here. We're going to say build, open up the parentheses. We're going to pass in r, comma, 1, comma, 0, comma, n minus 1. And that's going to build the tree from the basket capacities for us once again. So now, still not done. We're going to come outside of this function and we're going to create another function that is going to remove the leftmost basket with capacity, or it's going to mark the baskets as used once we've used that basket. So for that, we're going to declare a variable called FAANG. Sorry, y'all. Remove leftmost, open up the parentheses, we're going to say underscore val colon, that's going to be an integer. Then we're going to say it's going to come outside the parentheses and it's going to return a boolean. Then we're going to open up the brackets. Now we're going to find the index of the leftmost basket that can fit the fruit. So we're going to say guard let idx equal find leftmost, open up the parentheses, pass in val, else we could open up the brackets and we could just return false, meaning there are no suitable baskets. Now we're going to come right here. We're going to use some recursion. This is going to be a recursion helper function to help set the basket's capacity to 0 and update the segment tree. So still inside the main function, we're creating another function called func. We call this one inner. Open up the parentheses. We're going to say underscore node colon. That's going to be an integer, comma. Then we're going to say underscore start colon. That's going to be an integer. Then comma, then underscore end, colon, that's going to be an integer as well. Then we're going to open up the brackets. Boom. We're going to say if start equals end. We're going to open up the brackets and we're going to, the leaf node is directly set to 0. So we're going to say tree, square bracket node. We're going to come outside of that, set that equal to 0. Then we come right here on the if, and we're going to say else. We're going to open up the brackets and we're going to say let mid equal, open up the parentheses, start minus end, come outside the parentheses and divide that by 2. Come underneath that, we're going to say if mid, or excuse me, if idx is less than or equal to mid, then we're going to open up the brackets and we're going to say inner, open up the parentheses, 2 times node, comma, start, comma, mid, and that's going to go left. Then to go right, we're going to come right here and we're going to say else. We're going to open up the brackets. We're going to say inner, open up the parentheses, 2 times node plus 1, comma, mid plus 1, comma, end. And once again, that's going to go right for us. Now we need to update the current node's maximum after the change. So we come right here underneath this else, and we're going to say tree, square bracket node. Come outside the square bracket, we're going to set that equal to max, open up the parentheses, tree, square bracket 2 times node. Come outside the square bracket, we're going to say comma, tree, square bracket 2 times node plus 1. Boom. Then, sorry y'all, come right here, and we're going to say, we're going to call enter by saying enter, open up the parentheses, 1, comma 0, comma n minus 1. And then we just need to, if it's successfully, when the fruit is successfully placed, we come underneath this and we say return true. Boom. Not done yet though, y'all. We still got another function to write. So our next function is going to be called find leftmost, and this is going to find the index of the leftmost basket with a capacity that is greater than or equal to the minimum val. So for that, we could come right underneath this. We'll say func find leftmost, open up the parentheses, underscore, min val, colon. It's going to be an integer. Come outside of that, we're going to say it's going to return an integer. We're going to say question mark. We're going to open up the brackets. Then we're going to use some more recursion and create another helper function inside this main function. Once again, we'll call it enter. So we're going to say func enter, open up the parentheses, underscore node, colon, that's going to be an integer, comma, underscore start, colon, that's going to be integer, underscore end, colon, that's going to be an integer as well. And we're going to come outside these parentheses and we are going to return an integer, optional integer. Boom. Now, if the max capacity in this range is too small, no suitable basket here. So we're going to say guard tree square bracket node is greater than or equal to min val, else open up the brackets, we're going to return nil. Then if the leaf node is found, it's going to return a suitable basket. So we could say, come underneath this, we could say guard start is less than end, else open up the brackets and we can return start. Boom. And then we come underneath this, we're going to say let mid equal, open up the parentheses, start plus end. Come outside of that and divide that by 2. Now we're going to search the left child first. If none is found, then we're going to search the right. So we come underneath that let and we're going to say return enter, open up the parentheses, 2 times node, comma, start, comma, mid. Come outside of this, and this is, so that's, we're going to search the left child first, and if nothing is found, this is where we search the right child. So we're going to say question mark, enter, open up the parentheses, 2 times node plus 1, comma, mid plus 1, comma, end. Then we need to start the search from the root by coming right here, and we're going to say return enter, open up the parentheses, 1, comma, 0, comma, n minus 1. Boom. Now, we're not done because we still need to call this in our main original function by saying fruits.count, open up the brackets. We're going to say, then we're going to open up the square brackets. Then we're going to say tree equals segment tree, open up the parentheses, baskets. Then we're going to come outside of the square bracket and we're going to say fn, come right here, We'll say exclamation point tree dot remove leftmost. Open up the parentheses and pass in F. So that should be all she wrote. Let's give it a run before we submit it, y'all. See how it runs. Okay, we have an error. Okay, let's see if we could figure out where this error is coming from. So, one moment, y'all. Oh, okay, y'all. I see what the problem is. This should be a plus sign. Start plus end. Sorry about that. This right here should be plus as well. Let's see if this, and that should be right. Now let's give it a run and see if this works. Let's see, and it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 515 milliseconds beats 100% of users with Swift. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the middle, or the top part of the middle. Boom. Then this is some more of the middle. Boom. And then this right here is the bottom part, y'all. And with all of that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.